Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what is data visualization in data science. So, defining the data visualization. So, visualization is nothing but way of representing the data or visual display of quantitative information and qualitative information as well, but so mainly we can able to concentrate on the quantitative information. So normally the data will be of two types, already I covered in previous slides, like qualitative and quantitative. So the qualitative data means we should not have any kind of measures, and for quantitative it is going to have some measures. Okay, so visual display quantitative information is nothing but the data visualization, and then we are going to map the data to visual elements and encoding the data with size, shape, and color, and storytelling and narrative elements. So these are the things what we have to know in data visualization. So what is the data we're having? So that thing we're going to be represent into visual elements and encoding the data with size, shape, and color, and storytelling or narrative elements. So normally we are going to discuss about what should be the explanatory data visualization. So for this explanatory data visualization, you have to find the insights and then the conservation uh, between the data and you. You have to be listened. And what we have to do is that so we have to present insights. So that should be very important. And so, what should be the data science project life cycle actually? So, what are the steps you have to be follow for this in order to implement for any kind of data science project? So, very first thing is that we have to be first do the data acquisition. So that means so we have to be gather the data, and what are the various sources that are available for acquiring the data. And in previous videos I already covered, so there are different types of sources like primary source and secondary source. And for this data primary and secondary source, what you have to do is so we have to be obtain the data acquisition, and then so once the data is going to be done, so we have to be prepare the data according to convenient of that application what you are going to do. And from that, so once the data preparation is done, then we have to be perform hypothesis and modeling task we have to be perform on the data. So once that one is done, so once the model is to be done, then what we have to do, we have to be uh, perform the evaluation and then interpretation. So this evaluation and interpretation means that we have to be uh, evaluated, and then how we're going to be interpret the data. So once that one is done, we have to go for the deployment. So deployment. So once the deployment is done, we have to go find what kind of operations we can able to perform on this, and what kind of automation also we have to be perform this. So these are the various tasks, various steps what we have to be follow in a data science project life cycle. So here, so very first thing is that acquiring the data is the thing. So how are going to gathering the data from multiple sources and preparing the data. So how the data is going to be prepared, and then what kind of analysis is to be done and what kind of modeling is to be done. you have to die. So before once the data is going to be prepared, so what you have to do is, so you have to be perform the analysis. So after that, you have to perform the modeling. So then after that, the steps will be this evaluation and interpretation. So we have to evaluate the data according to that, and uh, then we have to be interpret the data. Then what you have to do is that, so we have final deployment. So what that should be a feedback, and what kind of operations we have to perform on that we have to be do, and optimization should also be done. So data acquisition, so data preparation, and then hypothesis and modeling, and evaluation, interpretation, deployment, operations, and then optimization. So data science process is the thing. So in this, acquiring the parser, and that should be the main theme of the Department of Data Science, and then filter mining is to be done where can able to perform this explanatory data analysis, and that should be done through the concepts of mathematics, statistics, and data mining, and some through graphic design. So we have to be represent, and we have to be do refine, and finally we have to be interact. So these are the things what you have to be done. And acquiring parser means data wrangling is to be done, and then explanatory data analysis, and so all this, the thing what I can able to take from this to this should be treated as a data visualization. Okay, so where can able to acquire this, and then parsing this should be done by through the computer science and mathematics and statistics, and through the concepts of data mining we have to perform the filter and mining process for extracting this explanatory data analysis. And for the graphic design, we have to be do this represent and refine define should be done, and finally we have to be interact this. So the concept of entire the thing we're going able to call as explanatory, and this thing what we call as the data visualization. Explanatory data visualization. So what should be explanatory data visualization? So normally this data analysis approaches will have so many things like classical approach and EDA and then Bayesian. So for this approaches, so we have to be perform what kind of approach we have to perform on this. We have to be identify. So once that one is done, then we have to be carefully identify what kind of approach is to be suitable for that. So if I'm going to take a classical approach, like, so we have to be identify the problem, and from that we have to abstract the data. Then we have to do modeling, analysis, and conclusion. So same thing we have to perform on explanatory data analysis, but so the only difference is that for the patient. So in the patient, so we have to identify the data, model, and then prior distribution analysis, and then conclusion. So EDA means, so not a set of techniques here, and statistical approaches, that means the quantitative and then graphical. So quantitative means hypothesis testing, and then analysis of variance and point estimates and confidence intervals and least square regression. So these are some of the approaches what is going to be there in quantitative approaches. And then if I go for the graphical statistical approaches, we're going to have scatter plots and histograms and probability plots, and then residual plots and box plots, and then black spots. So these are the some of these tasks or approaches what we are going to have for the implementing explanatory data analysis. So this explanatory data analysis, we have two types of approaches like statistical approaches, and these statistical approaches what we call it as a quantitative, and So quantitative means hypothesis testing and ANOVA is another thing, analysis of variance and point estimates, and then confidence intervals and least square regression. So these are some of the quantitative statistical approaches. Similarly, if I go through this graphical one, then we have to go for scatter plots, histogram, probability plots, residual plots, loss plots, and then black plots. So these are the other kind of graphical approaches. So already you know that. So what should be the graphical statistical approaches we are going to be have. So for this, scatter plots is the thing. Graphical means a scatter plot, histogram, probability plots, residual plots, box plots, and then black spots. So for this, you know what kind of the things scatter plots already you know that. So are going to be represented, and histogram is the thing under thing where able to represent the data explanatory data visualization, and the probability plots is the thing where able to implement and residual plots and then box plots assess. So this is the scatter plot is the thing, and this should be the example of bar graph, and then box plot should be like this, and then blocks plots like this, and then line graphs and histogram. So like this already I covered some of the topics what I'm going to be discussed in previous videos. Explanatory data visualization, that means graphical analysis procedures where able to implement these testing assumptions, and then model selection, model validation, and estimated selection, and then relationship identification, factor that is going to affect the determination, outlier determination. So these are some of the graphical analysis procedures we have to be for. Testing assumptions is the thing, and then model. So what kind of model you have to be selected? We want to have different types of models, and model validation is to be done, and estimator selection is the thing, other kind of the thing, and relationship identification, factor determination, and outlier determination. So all the things we have to be get from the insights of the data. And explanatory data visualization is mainly going to be done in design as well as engineering, and then and journalism. So these are the things we're able to do that. So explanatory data and visualization is to be done in the designing part and engineering part, and then generalization. So explanatory data visualization, so it should be a both an art and science, and we're able to show the visualization, and it should be the graph of art also, or I can able to show make visualization as the science also. So normally the visual encoding of the data. So normally these data types will be of different types like quantitative and categorical. Quantitative means we're able to two types of things like continuous and discrete, and categorical means we're going to have nominal, ordinal, and interval. So normally the data what I'm getting should have to be very clarified. So what kind of data it is we have to identify. So quantitative or categorical. So quantitative means continuous and discrete, and categorical means it should be a nominal, ordered, and interval. So these are some of the references what I covered from this video. So in this video, what I'm going to explain is that we're going to be see what should be the data visualization. So data visualization is nothing but the visual display of quantitative information, and mapping of data to visual elements is the thing, and where we can able to encode the data with shape, color, shape, and size, and then storytelling and narrative elements as well. So defining data explanation means so we're able to find out what are the insights and what kind of info conservation between the data and you should be identified, and explain what kind of insights is to be identified, and what are the major project life cycle in the data science should be. So data acquisition is the thing. So where we're going to be gather data and what are the various sources of the data, and data preparation. So data preparation also to be very important. So what's the data we're getting, so how we're going to prepare that, and hypothesis testing. Hypothesis testing is also be done, and then modeling should also be done, and evaluation and interpretation also to be very good here, and what kind of deployment and operations and optimization is to be done. So these are the things we have to be very careful. For evaluation and interpretation is to be very precious still. We're unable to iterate this process until we are going to be good results and in good interpretation. And finally, we have to be sent the deployment stage, that should be where we're able to get the feedback from the customer like this, and where I can able to perform the operations as well, and we can finally optimize it. So data science process is the thing where it should be of different phases. So very first thing is that we're unable to acquire and parsing is the done, that should be mainly done by the CSE, and for filtering and mining we have to make use of this um, mathematics and statistics and data mining, and this for the graphic design we have to be represent and refine it, and we have to be interactive, and finally all this combination of these pages will be treated as the data science. And explanatory data visualization, so it should be different types of approaches what we're having here, and for this we're what we're going to have like classical analysis of data approach, and EDA, explanatory data analysis, and Bayesian data analysis. So, like this, we're going to have different types of data analysis approaches we're having, and EDA is the thing we're able to approach that not be a technique here. And some of the statistical approaches what are going to be have in while data is quantitative means we're able to perform this hypothesis testing and analysis of variance is the thing, and so the point estimates and confidence intervals is the other kind of approach, and least square regression is the other kind of approach what we're going to be have. And for this graphical explanatory data analysis, we normally are going to have scatter plots, histograms, probability plots, residual plots, box plots, and then log plots. So explanatory data visualization, that means that scatter plots, histograms, probability plots, residual plot, box plots, and blast plots. So already I covered. So what are the different types of plots we're having for explicitly data analysis, and so how we're going to construct it. Everything I covered in previous video. And what are the different graphical different the things analysis procedures what we're having for representing that. So what kind of analysis procedures we are having means, so testing assumptions is the first thing. So what are the insert assumptions we are taking for testing or for analyzing the data, we have to be very careful. And then what we are going to have different types of model selections also. So for this model selections, so we have to be what should be model is to be considered, and what kind of model is going to be validated we have to be think. And estimated selection also be good, and the relationship identification and factor effect determination outlier detection also be done. Explanatory data visualizations are normally going to be applied for design, engineering, and journalism. So explanatory story data Data visualization means so normally should be an art of science, and we're able to show the visualization not only in the form of graphs, plots, so can also be show it in the form of art also, and then can also be show it in the form of uh, charts and then science way of representing. So normally the visual encoding of the data is the things we're able to see different types of data like quantitative, like continuous and discrete. And for the categorial, it should be nominal, ordinal, and interval. So normally mm, so quantitative means it should be a continuous one, and discrete, and categorial means nominal, ordinal, and then interval. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.